Okay, we're going to look at the idea of independent and dependent events, okay, in probability. Um, First, what does this mean, independent or dependent? Well, a number cube is rolled twice. Okay, so you've got a 1 to 6 sort of cube and you roll it. And then you roll it again. We say those two events are independent because one doesn't affect the other. It has no influence on the other. It won't. So we can actually say those two events are independent. And because of that, if they're independent, like say with rolling two dice, the probability of say getting two ones would be 1/6 times 1/6. We can multiply their probabilities, and that's it. We will figure out the probability of two things happening in a row. That's if they're independent. But what if it's two events are not independent? What would that look like? Well, say it's raining outside is one thing. Either it's raining or not raining. What's the chance of that? Okay, that's a probability. But then the parade is canceled. Well, the thing is, if it's raining, it's going to have an effect on whether or not they go ahead with the parade. They might go ahead, but the raining, the first event, will affect the second event. We say that's dependent. Um, Here's another um, dependent event. You draw two cards, one after the other, from a deck of cards. But the first card drawn, you don't replace it. You just hold on to it. Well, if you don't replace it, you don't have 52 cards anymore left in the deck. You've changed the total number. So it's dependent, and it kind of depends on what kind of card you pick. One event will affect the other. Okay, but how does it come up in exam questions, this idea of independence and dependence? Well, the whole thing is about this. If they say anything, they want you to test to see if two events are independent. This is what you do. First, write down this formula. The test for independence is the probability of A intersection B, A and B, equals the probability of A times the probability of B. Well, all you do, say you had that Venn diagram we talked about a little bit earlier, people liking apples and bananas. There's 4 people that like both apples and bananas and 5 people that don't like either. Group of 25 people. Okay, what's the chance? We can look at this diagram. What's the probability of A, people that like apples and bananas? Well, there's 4 people there, so it's 4 out of 25. Now we want to check and see if it equals the probability of A, which is 5 plus 4, that's 9 over 25, and the probability of B, which is 4 plus 11, 15 people like bananas out of 25. Well, you multiply these two fractions together on your calculator, and you see that you don't get the same number as 4 over 25. Well, if it doesn't work, if this rule doesn't work, therefore we can say that A and B are not independent events in this situation here. So that's the test for independence. If they say anything about independence, is it independent or not? Always write down the rule and then look to put in the fractions. And that's how you do the question. That's all there is to it. Not too hard. Pretty easy. Okay.